previous work in this has been done on students in introductory biology. But here we're really trying to focus on that general student cohort to get a better idea of how we can try and reach different types of students. I would also mention that if you are interested in talking with me or tweeting about this talk or just finding me, I'm Dunk Ryan on Twitter. I'm also tweeting for my lab at Evolution SU at Syracuse University. Awesome. So I'd like to start with this quote from Religiosity, and you may have seen it before, that nothing in biology makes sense except in the light of evolution. And when Religiosity said this, what he meant was that a bunch of different varying things that we see, such as beak morphology in Darwin's finches, mammalian limb homology, and even Hock's developmental genes, all make the most sense when you describe them through an evolutionary lens. However, we know that not everybody accepts evolution, right? So here we have a picture from the Creation Museum of dinosaurs living happily alongside human beings. We know that there are prominent politicians that do not accept evolution, even prominent politicians who are in charge of educating our nation's children. And this isn't a minority belief. So in a recent poll from Gallup, when asked about their thoughts about the creation of humans, about how humans came to be, 42% of people agreed with the statement that God created humans in their present form in the last 10,000 years. So that's a recent special creation of human beings, which we know goes against all of the evidence to the contrary. And this has remained unchanged for more than 30 years. So they've been asking this question since 1982, and following on this top green line here, we can see that it's always been around 40 to 45%. So all of the things that we're trying to do to reach students, to get them to accept evolution more, all of these great ideas that we come up with, aren't working in general in this case, right? They might be working with individuals, but we're not seeing that shift that we would hope to see when we're doing that. So what can we do? Well, in a recent publication in Nature, Ecology, and Evolution, I was joined by 20 co-authors to try and lay out what we know about evolution education so far and what we can do to do better in the future. I do want to just give a shout out to this author group because we did try to create a really diverse author group. We had authors from 3 different countries, 13 states in the US and DC, and we had a bunch of different types of institutions. So these aren't all professors at R1 institutions, right? We got people representing R1s, but we also have people that are teaching at comprehensive universities. We have people that are at museums. We have people at nonprofits that are interested in education, really trying to make sure that what we suggest here is something that can be applied broadly. So what do we talk about? Well, for one thing, we really talk about this model that we have of acceptance of evolution. This has been supported by work from some of those co-authors, myself included, that tend to find a few major factors that are associated with acceptance of evolution. So the one that you're probably thinking about is knowledge of evolution, right? And that's a big one. So knowledge of evolution does have an impact on acceptance, and they're associated, right? So the more you know about evolution, the more you accept it. Not too surprising. But that's not all there is to it. One of the other big things that people also think about whenever I tell them this is what I study, they say, oh, it must be religious people. And yes, okay, we definitely do find that religion has an impact. What we tend to find is that rather than looking at denominational effects, so rather than looking at if somebody's Catholic or Protestant or Muslim, it's more important to focus on the religiosity. So that's a measure of how they use their religion to understand the world, how deeply held that religion is, the intensity of that religious belief, essentially. And that tends to be a more helpful measure. And we can see, I do this little truncated arrow here, because that has a negative relationship, right? The more religious you are, the less accepting of evolution you tend to be. But what I think is really interesting is this third factor here, this understanding of science. So it's understanding the nature of science. You may be familiar with the idea. Nature of science being sort of the aims of science, the process of science, history of science is included in that. Right? It's really about what science is and what it isn't. And we find that that also tends to be positively associated with acceptance of evolution. So students who know more about how science works tend to be more accepting of evolution. But it wasn't enough just to talk about what we know. What we really wanted to talk about was what else do we need to do? Where do we need to grow? Where do we need to see the field going? And so we had 3 recommendations for that. One is to use more diverse samples. We just heard a little bit about diversity and its importance. And so part of that idea is trying to use those diverse samples with that attempt to increase acceptance in historically underrepresented populations. And also just to not contribute more to the erasure, right? So when we survey a lot of these students, we tend to have, majority white students, at with certain affluence and that kind of thing. And we want to try and move away from that if we can towards serving all of our students in a good way. The second thing that we suggest is that we need to do more longitudinal studies to observe changes over time in evolution acceptance. Right, so we have that one Gallup poll, but we really need to do that in a way that's more comprehensive, that's really contributing to some of the bigger issues that we see. And we want to do that both population-wide, that's kind of that Gallup poll, but also on an individual level. How do individuals change? And not just change in their acceptance, but also do those factors in association change? Is there a difference in the importance of those over time and the relative associations we see? And so if you're interested in the second one, I'm going to talk a little bit about it during this talk, but I also have a poster. You can see this poster board on here if you're up close. Today, poster board number 43, I'll be there. I've got some stuff that focuses really specifically on that. I'd love to see you all there. But for most of this talk, I'm going to focus on the first part. I do want to say, unfortunately though, not looking at those historically underrepresented populations themselves, but rather just looking at a diverse sample, as I mentioned at the beginning, a general student cohort. So the student population, as you may be able to tell from this beautiful picture, is at a private R1 university in the Northeast. And there's a lot of things that are associated with that are also true of the student population. So it's majority white. We have students who are less often Pell Grant recipients than you would expect, so it's about half of the national average. And due to previous data that we have at this institution, we know that students tend to be Christian or a-religious. So we do certainly have Jewish students, Muslim students, but we have less than we would like if we were really trying to target those populations in a meaningful way. So we surveyed students in a first-year forum course. This is kind of that introduction to college class that you may be familiar with. A lot of institutions have this type of thing. And so it's all arts and sciences freshmen, introductory freshmen are taking this class. And we administered those surveys at the beginning and the end of the fall semester, again online. And we calculated normalized change across the semester. So what that normalized change measure is really trying to help us understand how much students change relative to their ability to change, right? So we know that if you're already kind of, fairly highly accepting, moving up a little bit is actually a pretty big impact if you're already maybe higher there, right? Whereas moving from like 5 points when you're in the middle maybe doesn't mean as much. Maybe that's not as big of a change. So it tries to normalize the amount of change across those different areas. And then we use those to do individual regressions on the MATE, which I will talk about in a second. I know it's you haven't seen this yet. And then we did a stepwise regression to address that as well. So the MATE is what we use for the measure of, for accepting evolution. So it's called the measure of acceptance of the theory of evolution, but MATE for shorthand. It's a 20-question measure. These are Likert scale questions. So again, from strongly disagree to strongly agree, as we saw in the first presentation. I've only put 13 on here because they wouldn't all fit. And I just want to give you a representative sample of some of what they look like. So you can see some of it's about age of the Earth. It's about how data supports evolution and just personal feelings about acceptance of evolution. So this is our outcome variable that we're interested in, right? Acceptance of evolution. So the independent variables we measured, we have a whole smattering. You can see that some of these are directly those same types of variables that we talked about and we had in that model, right? We have evolutionary knowledge, we have religiosity. Here we're measuring both intrinsic, which is what I talked about before, that personal religious belief, and extrinsic, which is more about how often you go to church, go to Bible study, that kind of thing. We have nature of science understanding down here, which I'm going to talk more about in a second. We have some other knowledge components. So we measured, instead of just general evolutionary knowledge, we measured specific misconceptions. We also measured genetic knowledge, genetic literacy. And this measure up here, openness to experience. So openness to experience is a personality trait. It's one of the big 5 personality traits. And it's essentially like intellectual curiosity. So how interested you are, how open you are to new ideas and again, new experiences. So what did we find? Oh, but got the nature of science still. So also I wanted to mention this nature of science scale is really cool because it allows us to break down the nature of science into 6 different components. So we can view science as a moral, as a creative process, a developmental process, science being parsimonious, and these last 2 are the ones that we tend to see being the most important, so understanding science as testable, and understanding science as a unified body of knowledge. So unified meaning that facts in chemistry, facts in biology can't all be used together, right? It's the same information. We're using the same processes to gather that, even if the individual types of experience may differ from one field to the next, the information is the same. So when we're looking at these graphs, we're going to see that normalized change of acceptance of evolution here. So that's going from -1 to 1, obviously from 0 to 1 is an increase. Same on the bottom, this is what's going to change. So here we have evolutionary knowledge. And we have an association of about an R-squared of 0.08. Now this might seem small to some of you that do really controlled experiments. This is not too bad for when we've got students' minds and brains and their feelings and attitudes. So you see an increase association with evolutionary knowledge and acceptance as we expected. We also see a positive increase here with genetic literacy and acceptance of evolution. Cool. When we look at that nature of science, we find a much smaller relationship between understanding science as testable, but we find, again, about double that when we're looking at that nature of science as a unified body of knowledge. Openness to experience didn't show a whole lot. This is something that has shown some relation in studies before, but it varies. So it's something that we wanted to measure to try and understand. And we do see a positive relationship, but we're unsure how some holds in some instances and not in others. So that's something that needs more exploration. For religiosity, we do see a negative impact as we expect. And that's for both extrinsic and intrinsic religiosity. So we put those all together into a multiple regression. And so this is on that change in acceptance. And we can see knowledge is important and it's positive. Religiosity is negative, as expected. For some reason, when we put it all together, knowing more about genetics actually decreases acceptance, and I have no clue why. So if you have any ideas, I would love to talk to you about that. And then I was really happy to see that nature of science is really sticking out here as a really important factor. So this is exciting to me because this is a good pedagogical target, right? This is something we can actually take and bring to our classroom and say, we want to teach students more about science because we know it has a positive impact on their acceptance of evolution. So in conclusion, we confirm that this model in a general student population. Again, that understanding of the nature of science is unified is really important. I also am gathering qualitative data on this, so interviews on that. With that, I'd like to thank my lab, I'd like to thank Syracuse University, all of my Syracuse grads who came to support me, SSE for funding me through the Rosemary Grant Award, and HHMI who's been funding my lab. And with that, I'll take any questions. Yeah.
Quick question. So this study was done at an R1 Northeast.
Yeah.
Some of the predictors that you have there to gauge their acceptance or not acceptance, the unified stuff.
Mm-hmm.
To what extent do you think the way that those types of questions are applicable to different populations who aren't going to R1 universities Northeast? Like, do they have the background to be able to deal with those predictor questions in the first place?
Yeah, that's a good question. I think that a lot of work would need to be done, right? We don't know how well we know surveys don't always translate from one population to the next. And so some of it would be about trying to make sure that if we transferred those, that we made that language, if we wanted to ask those same kinds of questions, maybe make sure the language fits. But the idea should be something that we might see across populations. So I'd be interested in trying to find ways to study that with maybe using different measures. So I'll get your question.
So did these students, this was a changeover a semester, but they weren't necessarily taking any science classes that semester?
That's right. Yeah, that's what's so interesting
So
about
it's
it.
just the experience of being in college for one semester?
It seems to be,
Okay.
yeah. But we can talk more about that here afterwards, or you can find me.